recording. What I'm going to do is I'm going to share my screen and let you start checking your answers to the homework that was due today while we're seeing if anybody else is coming in, and then we're going to talk about what's going to happen tomorrow. So let's see who's here. I saw Emma. No, Cindy, Lily, Fiona was going to be absent. Angelica's here. Jacqueline's here. No, Vivian. Catherine. Julia, Sarah, Daisy, Lawrence, Susan, Claire. The only one we're missing is Nancy. Okay.
Fiona was having computer problems.
Who was?
So Fiona.
Yes, she emailed me. Thank you, though, for telling me.
Okay, cool.
I appreciate that a lot, Sarah. But she did email me this morning and said that, too. Oh, good. And Cindy's here now. Okay. All right, so we're going to come back to this, but I think everybody who's coming is coming. So I want to talk about a couple things, okay? So first of all, the College Board has now posted sample questions for your exam. If you have not done them, please don't. Okay, what we're going to do is tomorrow in class, we are going to do that. Okay, so please come to class tomorrow prepared as you would be to take the actual exam on Tuesday. Okay, so come with either a Google page open, a Word page open, OneNote, whatever you're going to do, but make sure you have a fake APID number and your initials at the top. Make sure they're labeled with the exam and pages 1, 2, 3, 4, 5. You can come with physical paper, please, and whatever handouts that you would have. Please have your method for how you're going to upload those images all ready, because I'm going to give you 5 minutes at the end and we're going to practice and make sure that if you're taking pictures and uploading and yada yada, that you have enough time to do that. Okay, so we will start class tomorrow with you doing those problems. They are in OneNote, so I'm going to share my screen again. This is the BC. The BC exam is slightly different than the AB exam. They overlap by about half, but the 4 of you who are taking the BC exam, you have both the BC and the AB in your OneNote notebook. Okay, so like Susan, I'm looking at you. You are in the BC class, but you're taking the AB exam. So you don't want the one that says BC, you want the one that just says practice exam. Okay. My AB only folks, you only have this exam. Okay. So like I said, we're going to do that tomorrow and then we'll go over it. I just want to remind you that one of the things that the AP website says is that you may not be able to answer all parts of all questions, and that's okay. You don't have to be able to answer all parts of all questions to get a 5. All right, and I feel that I did those practice questions yesterday so that we had answers, because the answers do not seem to be available. Although the website changes every day. But I felt that there was nothing there that was not part of what we had been reviewing. Okay, so everything that you are being asked to do is stuff that we've been working on. Lauren, what's up?
Dr. Getz, what if I've already done the question?
Well, then you'll just have to spend your time doing something else tomorrow. Okay, and you can certainly sit here for the 25 minutes and then you can go over them with us so you know if you have the right answer or not.
Okay.
And actually what you could do is you could do the, I will try to, well, it's there. You can do the AB question. Did you do both sets?
I think I just did the BC.
Okay, well, the AB has a part that's different. And it's
Okay.
certainly material that you are responsible for, so you could do that.
Okay.
Okay?
Okay. Thank you.
Sure. All right, any other questions? Okay, then let's go back to sharing my screen. Let's go back to here. Has everybody had a chance to check their answers then? And are there questions?
Can we go over B for the 2015 question?
Sure.
Thank you.
We must, well, okay, we're all right. I just spilled, sorry, you don't need to look at my chest. I just spilled water all over my table when I moved my notebook, but it's okay because it had a lid and it didn't get into my computer and we're fine. Okay, sorry. Okay, so are there any other questions on the 2015 number 6 problem? Does anybody need to see part A? Okay, then we will just move to part B. I just didn't want to have to go back and do part B. So this is, what?
Can we also go over the part C?
Part C?
Mm-hmm.
Yes, but we'll do B and then we'll do C.
Thank you.
All right, so we have this curve, y cubed is equal, no, I'm sorry, that's not true. Y cubed minus xy is equal to 2. So we're doing type 7 problems, and type 7 problems have to do with kind of 2 categories of problems that come up, but they don't come up often enough to be their own categories. And so 1/2 of the type 7 problems are implicit differentiation, which is what this is. And then later today, we'll go over the other part, which is related rates. So part B says, find the coordinates of all points on the curve at which the tangent line to the vertical, or the tangent line to the curve at that point is vertical. So This is a calculus class. What's one of the things we do in calculus?
Algebra. Derive.
Derivatives, thank you. Yes, we do algebra, but you do algebra lots of places. We take derivatives, right? So if I was sitting here, I would ask myself something about derivatives, okay? So what does a derivative really mean?
Slope of the tangent.
Slope of the tangent line, okay? So if I want my tangent line to be vertical, what's the slope of a vertical line?
0.
0. No, I'm sorry, it's not 0. What's the slope of a vertical tangent line?
Undefined.
It's not, well, yeah, or infinity. Okay, undefined works, but
Sorry, I was thinking
works
about
too.
horizontal.
I know, that's okay. So if I'm talking about this vertical tangent line, then I want dy dx, well, I want it to be undefined, as somebody just said. And the way I can do that is by having the dx part be equal to 0, which is really where you would get if you had a vertical tangent line. Delta y over delta x. For a vertical line, delta x is 0. So one way of looking at this is to say that what I want to take is dx dy and set that equal to 0. Now we did this at least once. It was a million years ago. It was in the chapter in which we did implicit differentiation, but we have done this before. You have seen it. And yes, I do at this point expect you to remember everything that we have done all year. That's the whole point of getting ready for the exam. Okay? But let's bring that up. So note that there is a difference between those two things. My top thing up here is the derivative of y with respect to x. My bottom thing is the derivative of x with respect to y. It's subtle, but they are different things. So what I'm going to do is take this derivative and set it equal to 0 and then find my points. Okay, so let's do that. So what I'm saying now is that my y's are my independent variable. So that if I take the derivative of a y, I get 1. End of story. If I take the derivative of an x term, now that is implicitly a function of y. So let's look at how this is going to work when I take dx dy. And actually, I'm sorry, I can't do that. I'm going to take the derivative with respect to y, okay? Because I'm going to have to use implicit differentiation because that is not an equation, this is not an equation that's solved for x. I could solve it for x, but I'm not going to. Okay? So when I take the derivative of my y cubed term, that's my independent variable. So that's just going to be 3y squared. If that's annoying you, just hang on for a minute, and I hope the next step will help you make sense, will make sense to you. Okay? My next term, xy, I need to use the product rule. So when I use the product rule, I take the first thing times the derivative of the second, and the derivative of y is going to be 1, plus the second thing, which is y, times the derivative of the first thing. And here, the derivative of x is going to be 1 times dx dy. And then that's going to be equal to the derivative of 2, which is 0. Because it's a constant. So let's just do some algebra. 3y squared minus, I'm going to distribute my negative sign, minus x minus y dx dy is equal to 0. And then we're just going to solve this for dx dy. So I've got y dx dy, I brought that to the other side, is 3y squared minus x. Or dx dy is going to be 3y squared minus x over y, and that's what I want to set equal to 0. And if I want this to be true, then I really need to have my numerator be equal to 0. And just kind of ignore the denominator, or you can think about it as cross multiplying. And this tells me that 3y squared is equal to x. So this is great, except that I need actual numbers. And how many variables do I have down here? 2, says Spencer. So how many equations do I need then, Sarah? 2, says Sarah's fingers. Okay, so where do I get another equation from?
dy dx?
Nope, because I don't know what dy dx has to be except infinity, and putting infinity into an equation is not going to help me.
The initial one?
Yeah, I have another relationship for x and y. And in fact, I'm looking for the points that have that vertical tangent that are on that initial relationship, on that initial curve. So what I'm going to do is substitute in for x. So that's going to give me y cubed minus 3y squared times y is equal to 2. Or negative 2y cubed is equal to 2. Y cubed equals negative 1. And when I take the cube root, I get y equals negative 1. And I can substitute that back into either equation, but it's easiest, I think, to substitute it in over there. And then that gives me x equals 3. So my point is 3 common negative 1. Okay, we good? All right, so Susan wanted to see part C as well. So this is going to be part C. And for part C, we're supposed to find the second derivative. Now, they tell us in the problem, I didn't realize that because I had a sticky note covering it. They tell us what the original derivative is, or what the first derivative is, excuse me. Okay. And then if I want to find the second derivative, remember that what I'm really doing is taking the derivative of the first derivative. And that's why when we write the second derivative, it's d squared y over dx squared, because my two d's here are next to each other and I have two dx's in the denominator. So I want to take the derivative of y over 3y squared minus x. And what kind of tools am I going to have to use?
Quotient rule.
Definitely. And what's the other tool I'm going to have to use?
Implicit differentiation.
You got it. Okay. So quotient rule says that I take the denominator times the derivative of the numerator. Now this is different than what we were doing in part B because I'm taking dy dx. So now x is my independent variable, y is my dependent variable. So the derivative of y is going to be 1 times dy dx. Minus the numerator times the derivative of the denominator. So that's going to give me 3y dy dx minus 1 all over 3y squared minus x squared.
Wouldn't it be 6?
Oh,
Why?
yes, yes, totally. And in fact, that's even what I said in my head. It's just obviously not what I said, what I wrote. Thank you. It's funny because I would have bet you $1 million that I had written a 6 because I know in my head it was a 6. Okay. And then I substituted back in for dy dx because I know what it is. So that's my 3y squared minus x. Dy dx is y over 3y squared minus x minus y times 6y times y over 3y squared minus x, that whole thing minus 1, divided by 3y squared minus x squared. I can cancel this and this. And then it's really just a function of substituting in x equals -1 and y equals 1. So that's going to give me 1 minus 1 times 6 times 1 times 1 over 3 minus 1 minus 1 all over 3 minus, not that many minuses, squared. And when you do it all out, that ends up giving you 1 over 32. Okay, we good? Another thing that they stress on the AP exams is not to worry about simplifying things by too much. So you probably won't have something that involves this much algebra, would be my guess. Okay. So are there questions on 2004, number 4? And go back to the answers for one more minute. But it's all kind of the same stuff. Okay.
For the exam, would they want justification in like a full sentence, or is it enough to be like local max at like 0.3, comma 2?
You'd have to show your work. So I would say something like, you know, horizontal tangent means, or whatever, what does it ask you for? Oh yeah, so like horizontal tangent means dy dx, you know, implies dy dx is equal to 0, dy dx, you know, finding dy dx and setting it equal to 0. For part B, or C rather, which is what you talked about, I wrote that I figured out what, well, I knew what d2y dx squared was. I acknowledged that at 3 comma 2 it was less than 0, which meant it was concave down, which meant that that point was a max. So you have to justify it, and that's actually what the problem says, is to justify your answer. So you got to make sure you have a chain of logic there. Okay.
If it doesn't say justify your answer, should you still do it?
I would, but they're not going to say don't justify your answer.
Right, right.
I mean,
They don't say anything, I guess.
they're not going to, well, they're not going to do that.
Okay.
I mean, unless it says, here's an equation for dy dx, find dy dx at x equals 1, y equals 4, then you just do the work.
Okay.
But that's just like a plug and a chug thing. But if they ask you, is the point 1 comma 4 a max or a min, you should show your work.
Right.
And,
Okay.
and say why you're doing what you're doing.
Yeah, that makes sense.
Okay, so what I would like you to do then is the example problem that is not this. The other type 7 problem, which is about related rates. So 2018 number 4 here from class. I'll let you work on it for about 10 minutes, and then we'll go over it. And then your homework, which is already on the portal, is to do the last homework problem associated with problem type 7. Okay, so please work on this for about 10 minutes. I'm going to stop sharing and stop recording. Pause. Okay, so I'm going to put up the answers. Oops, that's not it. This is it. So that you can start checking. And I'm kind of guessing that we're going to have to talk about part D, but why don't you start checking your answers, and then we can go over what we need to go over.
Can I just see what value you had for h for the trapezoidal rule? Because I think that's where I went wrong.
What do you mean the value I had for h?
Is the h just in Simpson's rule?
Yeah. Yeah, h is just in Simpson's rule. Usually when you're doing it with the trapezoidal rule, you really want to remember that what I find is that each trapezoid is 1/2 the sum of the bases times the height. And the height, because remember the trapezoids are all on their side, so this is h. The height is like the width of the interval. So for instance, on the problem that you're supposed to be working on, you know, these are going to be my intervals. So the height of my first trapezoid here is going to be 1. The height of this trapezoid is 2. This one is 2, but this one is 3. Yeah. Okay. Does that help, Emma?
No, I still.
Okay, well, let's talk about how to, do you want to ask a specific question or do you want me to show you how I did it?
Can you just show me how you got the values?
Sure. So let's go look here so we can actually look at the table. Okay, so like I said, each trapezoid, it's going to be 1/2 base 1 plus base 2 times the height. Okay, and these values here are going to be the B1s and the B2s, and these differences here are going to be the H's. So we're supposed to do this from t equals 2 to t equals 10. So my first one, that's going to be 1/2, excuse me, base 1 is 2, base 2 is 1.5, or the other way around, it doesn't really matter. And my height is 1. My second trapezoid, 1/2, now I'm looking at these values. So my bases are 2 and 6, and the height, or that width of the interval, is 2, because 3 minus 5 is 2. This is going to be my next set. So I've got 1/2. My bases are 6 and 11. My height, again, is 2 because that's 7 minus 5. And then this is my last trapezoid, so it's 1/2. My bases are 11 and 15, and my height, or the width of my interval, is 3 because that's 10 minus 7. And when you add that all up, you should in fact get 8.2.
I don't know how you get 8.2.
Well, you do. I get 65.75 divided by 8. So if you agree with this, and
and then you divide over the interval. Okay.
No, you're going to add up all those numbers and do all that math that's right there in front of you. And when you do that, you should end up with 8.2. Oh, yes, you do. Right, because you're supposed to find the average value. Wait, part C. Oh, yes, to find the average value. Yes,
Okay, that's
you
why
do.
I was confused. Okay.
Okay, yep, and I wasn't answering the whole problem. So yeah. So this gives you the area, and then the average value is 1 over 10 minus 2 times whatever you get from there, which is 65. Okay, I understand your question now, Emma. You wanted the 65.5, right? 65.75, which was the area. And then that's a minus sign. Thanks, Sarah, for clarifying that. Okay. How about part D?
I need help with that one.
Okay, let's talk about part D for a minute here. All right. And I think just reading part D can help. So part D says the height of the tree in meters can also be modeled by the function g, given by g of x is 100x over 1 plus x, where x is the base of the tree in diameters. When the tree is 50 meters tall, so that 50 meters tall corresponds to g of x, the diameter of the tree is increasing at a rate of 0.03 meters per year. So this is dx dt, that 0.3. And the g of x is 50. According to the model, what is the rate of change of the height of the tree with respect to time? So this is dg dt. And that's what you are looking for, is dg dt. But you don't have g as a function of t, you have it as a function of x. So I want dg dt, but what I could easily find is dg dx, and then use chain rule to find dx dt. And we did this a lot back in chapter 5, the end of chapter 5, when we did related rates. Okay. And so you can find all of those things and then evaluate them when g of x is equal to 50 meters. So the bell has rung. Try it now knowing that. Okay, and then the homework is to try a second problem like this. But you know how to do this. You just have to, I think about it a little bit. Okay, and then please remember to come tomorrow prepared to take a practice test. All right? All right, you may go. Bye, guys. Cindy, class is over.
Sorry, my internet is not
Okay.
good.
All right. Well, class is
Bye.
over. I'll see you later. Bye.